So, screw you. Glad I got that part on camera. Yes, screw you. So wait, so I got two suggestions now. I'm going to do an optimization problem. And Marsha, you want to do that? The definition of derivative? No. I mean, please. You gotta know, I mean, the biggest...
Is it just the f of x plus h over... Okay,
yeah, I mean, that's what it is. It's something that answer. Yeah, so that should be easy peasy. Especially if it's a polynomial I'm giving you.
What is that? That's what definition is.
Oh, shit.
Definition of derivative? Yeah, that's before the...
Yeah, dude. What is f of x? What did it take place of way back in the day? Y. So isn't this y2 minus y1, and then we realize that that's x2 minus x1.
Yeah, that was just slope.
Good, and that's why derivative is defined as the way it is. Derivative is the... Holy shit! A little bit late, but I don't care when that goes off. Like, that's why it's slope, because it's slope. But no, not teasing. I mean, that's all. That's it. That's all it was, right? That's why derivative is slope. The first thing we did was very algebraic, and the only thing that made it calculus was adding the idea of limit in, and that's why we took a while to even figure out what the hell limits were. Okay, so that is just y2 minus y1 with the limit added. That's that one little bit makes it calculus. So it's not very far away from algebra at all. Anything else? I love you guys.
We'll grab talk too.
Oh yeah, there was what? There was optimization problem. Somebody just wanted an optimization problem. Okay. And then we'll look at f-talk. Sounds like some Klingon word. It means cup. F-talk. Oh, maybe it does. I don't know. Anybody know Klingon? F-talk? So a problem like, I don't know, I mean, if I were you and I'm trying to study for the optimization problem, I would do several of different types. So there's a certain type that is find the point on this curve that's closest to this point, right? There were several in the homework that said that. That's a classic optimization problem. Minimize the distance between two things. And then another classic one is something you don't think is a single category, but it is. It's given this shape, minimize the surface area needed for a certain volume, or vice versa.
Also, for like equations, because remember the test like you helped us kind of with equations, like on that kind of stuff, like shapes.
Oh yeah, well if I ask you for the volume of something weird, I'll give you the formula. Yeah. And you're like, define weird. Everything is weird if you think about it, Jeff. Come on. I don't know. So okay, without any, we'll do that. Ooh, I like it. That's gross looking. So this one says, find the area of the largest rectangle that can be inscribed in an ellipse. What's the matter?
This is interesting. You picked a problem.
Yeah.
Not that one.
We'll blow them out. All right. Find the area of the largest rectangle that can be inscribed in the ellipse. Ooh, I like it. I like this in so many levels. The least number of numbers that you can have. So I have this rectangle inscribed in an ellipse. For me, that's, well, even for me, that's still crap at all. So the biggest problem with optimization problems is you have to realize what variables you need to create or what variables already exist. So what do I need to know about this rectangle in order to get its area?
I want to know where it touches.
Dimension. Yeah, okay. So I need the side lengths, and that somehow is going to be, it's got to be related to where it touches, because those are the points that actually follow this formula. So you have to use the restriction somehow along with
Can we make that equal to the equation for a square or rectangle?
No.
Okay.
No. What is this equation for?
The ellipse
And what does that mean? Any point that works in it,
equals 1.
no, that's what it means to work in it. Any point that works in it is on the ellipse. So these points are a collection of things that work in this equation. That's what it is. So setting it equal to an area doesn't make any sense. This is a collection of points. I mean, they don't equal an area, right?
Okay.
So what they're going to help me do, though, is eliminate one of my variables. So I am going to have like two variables here. Whatever this length, for the moment, let me just call this L, and I'll call this W. That's heinous because it's already too many variables. I already have X and Y. Now I got L and W, so let's do better. So what is this really? Well, it touches there, right? And what point is that? Don't overthink it. What point is that? XY. Where Y follows this pattern here, right? Let me stop here for a second. I mean, I think for next semester, I'm going to make a suggestion to the math department that we do early in the semester a thing where pre-calc students, calc students, 280 students, 281 students can come and just talk about how to set up freaking variables for a problem. I mean, that's such a fundamental thing to be able to do, and I think that's what held a lot of us back this semester in here, is we haven't done enough of that. But I've identified what I need to know about this, but I want to write them in terms of this equation I was already given. So, like you said, a big thing to realize, Cameron, is that I have to use the restriction. That's where it hits, and then I know that's true for this point. So what is this?
2y.
What is that?
1y.
No, come on now.
0
That is
0x.
X. That's X. And what's this?
0.
0y. So it's Y on that Y. I love it. So what's it got to do with shit? Well, so what's this whole thing?
2y.
2y. Oh my God. So now we're starting to connect my shape with the restriction that's on the ellipse. I'm connecting those two, right? So this is 2y. So what's this?
2x.
2x. No way. Stay with me. So what's the area of that? Because that's what they're asking me for. So remember, really key thing. We learned this on that test about the cost with the one side of the fins costs more money. When I say minimize the blank or maximize the blank, get a function that represents blank. Because you have to, unless you have that function, you can't attack it with derivatives. So if it says minimize the surface area, now you're going, I need an equation for the surface area so I can attack it with derivatives, right? Kill it with fire. What is the area here then?
4xy.
4xy, I like it. Cool. So now you can see why I want it related to this, because now I can eliminate one of my variables.
What about the a squared and b squared?
Well, what are those? What are those?
What are those?
There's just numbers I don't know. So they change the shape. So the way I've drawn it doesn't really matter, but it could have been like this, right? Could have been the UFO turned this way to take off, right? All right, maybe. But does it matter mathematically? No. Math doesn't give a shit what A and B are, as long as they're legal. They're not 0 or something, right? All right. So this is a problem that's more general than if they gave me an actual specific ellipse. 9 and 16 would have told me the semi-major and semi-minor axis and all that kind of crap, right?
Okay.
Who cares? For right now, they're just things to carry around, really. How do I solve this for what? Let's solve it for Y. We like having X and things. How do I solve this for Y? That's a good first step.
1 minus x
Yeah.
squared.
Yeah, subtract that over.
Then multiplied by b squared.
I like. Is that cool? There's a myriad of different ways to write that.
Square root.
Yeah, and then you square root for that. I like it. That's gross.
Yeah, this is
It's too bad. And I'm gonna. Let's see if you guys are cool with this. Plus or minus doesn't really matter here because I'm talking about the length of something in physical reality that the math cares that the y-coordinate could be negative. I don't care. I just want the length, so I'm going to choose the positive one. Is that, you guys, does it make sense?
Yeah.
Okay, good, thank you. So now you just throw that in. I mean, I really, and again, they tell me this, and they ask me this. Use what they tell me in what they ask me. I've said this all before, right? But the key thing, I think that's hard, is not easy. I'm not saying it's easy, but I'm saying you got to even be able to just try. Come up with variables that define what it is you're working with. Not L and W. You want them based on something else. They normally you want it based on something to do with what they tell you. So that's why I wanted to bring X and Y in here, so that I can use this the way I'm about to now.
We can take B.
Yeah. You could take B out, whatever you want to do. You can take A out too and make this B over A, square root of A squared minus X squared. If you wanted to. Right, square root of B squared is B. If I take A over A squared out, can you guys see how I got here?
No, I believe you though.
You do?
I believe you.
Watch. Make them have the same denominator. Do you see that?
Okay.
Right. So then take B squared over A squared out, basically. And aren't you left with that? Why is it B over A? Because it's the square root. All right, cool.
Okay.
Did it really have to do that? Not really, but that looks better.
It does look a lot better.
It looks better.
Yeah.
So the simplification process is another thing that we seem to not be getting enough practice on. So I've got to find my pre-calc teachers and slap them into shape. Right? Yeah, it's like, don't touch mine. You just go whatever. Didn't do enough for you. So that I can plug right here. B over A, square root of A squared minus X squared. Now should start the easy part. And the nice thing is, what you desperately have to get used to now is integrals require certain things to be present or I can't do shit. Especially right now, because we only know one thing, really. We know U sub. Right? So does that make sense what I just said? If there are certain things that are not there, I'm screwed. Derivatives don't give a shit. You can attack anything with the derivative. Anything. You can attack it. That's the difference. Yes, sir?
Product rule, right?
Yeah, I'm going to need product rule. I like it. Let's write this a little bit better. So I got 4b over a x times this. So now I've really got my eye on what my functions are. That's just the constants got to come for the right. So now it's derivative. Now it should be easy. The hard part is setting up the function that I want to attack. This is all about finding the maximum area. So now I'm going to take a derivative so I can find that maximum area. I like it. You guys semi-cool that? I mean, I almost want to be able to stop there and just say the rest is easy.
Can you tell us the steps that you would do in finding the max area?
Well, here, I mean, in general, how do you find the maximum anything?
Look for the zero.
Derive and set to 0.
Take the derivative, set its derivative equal to 0. So if I ask you to find the maximum velocity, what are you going to set equal to 0?
Acceleration.
Acceleration. If you set velocity to 0, that's not good, right?
Well,
Find the maximum velocity. Well, I'm going to set velocity to 0. You just, what? So if I ask you to find the maximum movement on blank, you set its derivative equal to 0. That's the positions that could be the max or the min. Of course, we have to check to see if it is, because it could be a min. That would suck. Right?
You try to check slightly above and slightly below.
Yeah, that's one way to do it. I like it. Yeah, exactly.
Okay.
Exactly. So to do this, like John said, it's product rule. But I mean, I don't know. Do we want to? I don't know. Do we need to? Let me write this like this. So what's dA dx?
So 4b over a squared minus x squared.
4b over a, derivative of that, times this. I like it. That's the first part of product rule, plus 4bx over a, right? Product rule, derivative of that, leave everything else alone. Now leave this alone, derivative of that.
1/2.
Correct.
Yeah. 1/4.
Sorry?
1/2 is
A squared
a
minus
squared
x squared.
minus x squared.
And chain rule.
Negative 2x, I like it.
Okay.
Yes. Now, of course, once you learn integration, the only thing you got to be careful about is, am I asking you to do a derivative, or am I asking you to do an integral, right? Changing those gears sometimes, right? What you been doing with this? Your brain. All right. And so, oh, this is yummy because you have to set this equal to
0.
Oh, it's so yummy. Now watch. If I set this equal to 0, which we know we want to do, I know I can simplify this, right? I can do that, no, blah, blah, blah. What immediately can I kill? Just let me get rid of a little something. Can you guys see what dies? What can I divide both sides by?
4b.
Any constant I can divide by, right? I gotta keep that. Can't divide by x because x could be 0. To be specific, because I can't divide by 0. So that's why you don't divide by variable expressions normally, because they could be 0. The constants, they're freaking constants that you can divide by. I know these aren't 0 because it's the size of the freaking ellipse. If it's 0, it's not an ellipse. You can't fit a rectangle into it. Alright, shut up. Alright. So what do we got here? We got a squared minus x squared, 1/2 plus x. Let's make it minus, right? Just clean this one up a little bit. Minus, the 2's went away. X squared. Alright. Is everybody with me so far?
Yeah.
So kill the constants. If we're going to set it equal to 0, kill the constants. Here's another thing. I don't know if you guys remember this, but I can multiply both sides by something that will make this go away. Whenever you see this happening, this is half of a whole. It would be beautiful. What makes it suck is it's a square root. That exceptionally sucks. Because all this stuff is stuck inside the square root. If I could just get rid of the square root. And I don't want to square both sides because then I have to FOIL this thing. Holy shit. So what's a better way to do that? How do I make this a whole thing? I multiply by
A squared minus x
itself. When I make it a whole, and what happens when I multiply this by this?
It goes away.
1.
It becomes 1. I mean, it's beautiful. So you see how 1/3 and a negative 2/3? You multiply that thing to the negative 2/3. I'm sorry. Multiply by, yeah, that thing to the 2/3, because that'll fill it in. That'll make that one 1, and that'll make the other one a whole 1. Do you guys see the idea? This happens so often in calculus because of the way the derivatives work.
It makes the exponent 0 or makes
Yeah, it makes that exponent 0, and it makes this exponent 1.
Okay.
So if I multiply by that to both sides, this side and that side, that stays 0. This becomes a whole one of these.
Okay.
Minus x squared times 1. Well, look at that. Look at that. That's the next line. I mean, can you believe that shit? And I don't care if you believe it, because it's true.
I saw it just happen.
I mean, this kind of thing, this is what I mean. This should be the meat of math. This is what you should have seen a decent amount of in pre-calculus to be able to get ready. That's the reason we call it pre. So I'm not saying it's your fault that you don't know some of these things or you're not as familiar as you should be. It just worries me about how it's being shown to you guys. All right. So how do I finish this out then?
Negative
A
2x
squared.
squared. That's
A
a
squared
constant.
equals 2 squared.
So x squared equals a squared over 2, right? So x is
Square root. A.
a over the square root of 2, right?
What? We don't know any of those.
I don't care. I want you to realize this is beautiful. So then what ellipse does this work for? All this work. What ellipse does it work for? Every ellipse. That's why this is so much better. We don't know what it is? Good. Somebody else can say, I got this kind of ellipse. Well then here's the length. There's the, the actual length of it would be what? Because remember, I took the picture away, but it was 2x by 2y, right? So what are the dimensions going to be? It'll be... What is 2 divided by half of 2? What's a whole 2 divided by... So I'm going to get this, right? What's that?
Ring 2 on the top, maybe?
Say again?
Ring 2 on the top?
Root 2, yeah. Right, what's 9 divided by 3?
3.
3. So what's 2 divided by its square root?
Square root.
Its square root. Right, there's a general truth. So that's that, and then to figure out what y is, you just use, do we still have here the relation for y? Right? Plug in that x, get what y is.
Oh, okay.
You'll know the dimensions of the rectangle. And then for any ellipse you want to give me in the universe, any ellipse you can imagine, I already have the answer for what the rectangle's dimensions are. That's the key. That's why we give you problems that don't have numbers in them, because then that's more powerful. I don't have to do every ellipse. Another ellipse? Let me do all this shit again. No, I've already done it for every ellipse that exists. Next. That's why math people like it when there's less numbers, because then it's more general, it's more useful, the results. All right. All right, and the crowd goes in. That's good. That's good for you guys. All right,
See
sorry.
all the other shapes.
Exactly. That's what I was thinking when I said next shape. What do we got? Got a hyperboloid. Oh shit, I'm sorry. Should see a doctor about that. So where are we gonna go next? I missed somebody, didn't I? What was the other thing somebody said that I skipped? Ooh, yeah. And then the trough part 2. This time is personal.
Oh, we said F-top.
Oh, okay.
Yeah, F-top 2.
Real talk, guys. Real talk. So you don't have to remember the parts, but you guys, you don't have to remember which one's 1, which one's 2. But there are 2 parts to the fundamental theorem. One of them dealt with, well, I kind of gave it away on number 2D, dealing. That was different than what I'm used to. Like, Math monkey is mad. I don't know what to do with it. So F-Talk 1 deals with the derivatives of integrals, and you should expect that to be easy on some level, because derivatives should undo the integral, right?
That's all.
And I already discussed all about why it works and how it works and so forth. So that's like 2D. And then in F-Talk, so I don't know, is that what the question is about? F-Talk 1?
F-top 2.
F-Talk 2 is the one you guys use all the time.
Hence why we should know it.
When I say do this, sure. When I say do this, you're using F-Talk 2, because F-Talk 2 is the one that says the integral of f from a to b is big ass f of b minus big F. That is F-Talk 2. We had to prove that. And we did.
You do that all along.
You've been doing it. Every time you plug limits into a result you get, that's F-Top 2. That's the fundamental theorem of calculus part 2. What'd you do today? I applied the fundamental theorem of calculus. So this is x cubed over 3. When you plug a 1 and a 2 in it, that's what you're doing. Is that cool?
Yeah, I think that's our position. Yeah.
All right, I like it. So if it references fundamental theorem of calculus part 2, just realize, they just mean the normal
Integrated.
definite integral process. That's another name for it. An everyday kind of name for it. I like it.
Labrador's rule?
L'Hopital.
Oh, L'Hopital's rule.
Oh, yeah.
I was saying Labrador's rule. I was like, yeah, Labrador's rule. I wasn't sure. Somebody on the other side of the room is going to go, no.
Golden retrievers.
Yeah. Screw your Labrador.
Largest Labrador.
Can we go over, when we know when to use it? In this
Oh, yeah. So what's the fundamental, not even that specific, just what type of thing do I have to be working with to even consider using L'Hopital's?
Zero.
A fraction.
A ratio.
Oh, yeah. Okay.
I like it. There are certain things like 0 times infinity. That is indeterminate, because 0 times anything is
0.
and infinity times anything is. So 0 times infinity, oh shit. So it all matters. This isn't really 0 though. We understand this is something that's going to 0, and this is something that's going to infinity. So what really matters is which one's getting there faster. Which is why L'Hopital's kind of makes sense. Right? But it has to be a ratio for that to work. That's what he hardwired it up to be. It's got to be a ratio to start with. So if I just flip this over, it becomes, and this is all in parentheses, infinity or infinity, which is your most basic indeterminate form. And the other really basic indeterminate form is 0 over 0, which is just taking that down and making it 0. Okay, so I mean, I had a problem on the practice test that was something like this. And this is one where people just start using L'Hopital's, but that's silly on 2 counts. First count is you don't freaking need it. It's not indeterminate. If it's not indeterminate, I can determine the answer. Why would I do anything other than that? So what do I mean by that? What do you get when you plug a 3 in? Yeah, 3 over 0. This goes to infinity. 3 divided by 0 goes to infinity.
Remember it says left or right?
Yeah, this is, why did I have to say this? Because I can't come at this from below. I can't put negative values in there. I don't want to go into the complex numbers.
Oh.
Yeah, that's the only reason that's there.
Okay.
All that really matters is this is over 0, so the answer is going to go to infinity. I like it. So please, you've got to make sure, and please, you've got to tell me. You know, so some of you guys look back at your test from L'Hopital's, and I was saying, why is it okay to use L'Hopital? Why can you do LH? Why? Just really quickly say it's in this form or it's in that form. I'm just trying to get you used to looking for that, because then you'll save yourself from this. You know, oh, it's not, oh, I'm done. Okay, good, next. Ellipse, no, okay. So, where are you going to use it then, of course, let me see if you guys can make one up.
Oh, dude, why pi? Cosine.
Yeah, I don't like pies.
Cosine.
I know you know, so that's why.
Cosine pi?
John,
Okay, so if you make it cosine y, what do you have to do? If you make it cosine x, well at pi that's negative 1, so you better put a plus 1. So now, so far we got 0. So the bottom, whatever you put on the bottom better go to...
X minus pi.
Yeah, it better go to 0. So the easiest thing to say is x minus pi.
X minus.
So the top goes to 0 at pi, and the bottom goes to 0 at pi. I like it. So it's in that form, so the L'Hopital says, no problem. You can take derivative. So what do you get? So now, this is how you show me what you're doing, and yourself. What do you get?
Negative sine x over 1.
Kick ass.
That's the answer.
And see, if you do L'Hopital's again, you will get an answer. More than likely it will be wrong, because L'Hopital's is not guaranteed to work unless it's indeterminate. Right, you might get lucky and it might come out to be right, but with algebraic trig functions, you're probably going to be wrong. Sine, cosine, they don't agree anywhere, except for a few places, but not here.
So sine of pi.
Sure, cool. I like it.
Will you put something, for example, 0 to the power of infinity?
Oh, I could, sure. There were these. So if I said, what you got, Jeff?
He wants the whole thing. The whole property.
Who would like?
1 to the power of infinity?
So 1
1 minus 0.
Oh yeah, this better. This would be better.
1 plus 0
1 plus 0 is 1.
to the infinity power.
Now, what is 1 to the power of infinity? What is 1? If it's just 1, what's 1 to the infinite power?
1.
1. I like it. Sounds like a good band name. We are 1 to the infinite power. But is this ever 1?
No, it's
No, it's always a little more than 1. Shit. So that's why this is indeterminate. It all depends on how quickly that's going to 1 versus how quickly this is going to infinity. So this is in the form 1 to the infinity, which on first glance, I understand, because I had the same reaction when I first saw that. I remember, I'm like, why is that? What do you mean that's 1? It's because this is never 1. It's just approaching 1. So this is the form it's in, but it never gets there really, right? So who remembers how I do this? What do I have to do because one of my functions is in the exponent? Good? When you get that out of the way, bring your own Kleenex, by the way.
Oh, yeah.
bring my gross fine Kleenex. It's really cheap. Yeah, exactly. So what am I working with? I'm working with this. I don't know if you guys remember this. Well, I guess I do.
So, ln.
And this looks a lot like a problem, x minus 8, ln of x minus 8. That's on the practice fund. So what you have to do there is what we're about to do. L'Hopital's only works if it's in
Fraction.
ratio. So can't I bring this down as long as I write it as?
Square root of x.
No.
1 over x.
1 over x. Multiplication by x is the same as dividing by 1 over x. These little things, like what I just did, have to be second nature almost when you come to a class like this, because it's going to happen anywhere. It could happen. Yeah.
So, is that line down?
What? No. So no. All I did is still. This is still ln y. All I did was simplify that, or not simplify it. Put it in a better form. So whatever answer I get when I apply L'Hopital's to this, I have to raise e to it to get what y would do. That's what that process is. So if I do the limit on this,
So you put it to 0 over 0 form now.
let's put this inside a little bit. Well, let's see if that works out. So can I use L'Hopital's?
Yeah, it's 0 over 0, right?
Yeah, well,